Hello, and welcome again to the tinyML Trailblazer series. My name is Evgeny Gusev from Qualcomm and also tinyML Foundation. tinyML Trailblazers is the place where you're going to meet people, leaders in this field who really drive tinyML technologies and tinyML products and tinyML applications. And it's a privilege for us to have these experienced people as our guests. Today, our special guest is Luca Verre. He's joining us from France. Luca is co-founder and CEO of Prophesee. It's a successful neuromorphic computing company. They've been doing this for quite some time and really getting good traction these days. And before we start, it is my pleasure to acknowledge our strategic partners. We have a couple of new names here, companies who joined in January. AZIP, Analog Devices, AON Devices, Adrena, ARM, DeepLight, HMPulse, PhotoHub, Gravity Inc., IBM, ImageMob, Innoterra. That's a new company based in the Netherlands. Also doing neuromorphic computing. ITMS, Clickertech, Microsoft, Nota, NXP, OctaML, Pollen Technology. That's another new company from Israel, actually, also doing neuromorphic computing. That's the neuromorphic field is growing. That's what Luca is going to explain also to us today. Prophesee, that's the company that Luca founded. Kixo, Qualcomm, Rixon, Renaissance, SAP, Schneider Electric, who also joined us recently, SenseML, Silicon Labs, Sony, ST, Stream Analyze, Synaptics, Syntiant, and TDK. See quite big and growing list, and if your company is interested, please contact us. And you're also very welcome to join tinyML communities. They are very active. We have 46 meetup groups in 37 countries. We have very active LinkedIn community, over 10,000 people there, and the links and the QR codes are there. A YouTube channel has a lot of tinyML videos, close to 9,000 subscribers there. Also kind of great resource to learn about tinyML. And this video is also going to be posted there tomorrow, and the link is there, so we also encourage you to go there and subscribe so you'll get notifications. Couple of really exciting announcements. So starting from last year, we are doing in-person events. So we are very excited about the upcoming tinyML Summit that will take place in the end of March. It's going to have an exhibition there. So we're going to offer our exhibition on Monday for free. That will be like tinyML open house, so that people can see the exciting stuff that is happening in the tinyML world. So we'll have tinyML research symposium focusing on the academic advances. So registration is open. You can go there and register. You can register separately for the research symposium or for the whole summit, for the whole event. Also, if your company is interested in submitting nominations for awards, and we're going to have 3 awards this year, just like last year: Best Product of the Year, Best Innovation of the Year, and Best Paper. So you can go and submit your nominations online. And again, it's going to be an in-person event, and there are still few spots left for sponsorship and for the tables. So we're even more excited about our next in-person event that will be at tinyML Europe, Middle East, and Africa Innovation Forum. It will take place in the end of June. Also, it's going to be an in-person event, and it will take place in Amsterdam, in Europe. Also, registration call for papers is open now. Deadline for abstracts is the end of February. So yes, if you're interested in being there and presenting, please submit it, and the committee will consider and will notify by March 10. At this point, it is my honor to introduce our host. It's Dr. Chris Rowan, Chris is a very well-known entrepreneur and technologist in the Bay Area and also worldwide. He's done a lot of companies in his past in the compute space, in the AI space. Currently, he is a vice president at Cisco after Cisco acquired his previous company, Bubble Labs, and he's in charge of ML and audio capabilities there. And again, Chris started several companies. Some of them are really well known and quite successful, like Silica. And he has many awards and recognitions that wouldn't fit on this one page. He has a formal degree in physics and EE, and again many recognitions. So again, thank you, Chris, for your passion and for being our wonderful host. And the mic is yours.
Well, thank you very much. It's an even greater pleasure to have a chance to introduce Luca. Luca is the co-founder and CEO of Prophesee, which has really become one of the leaders in advanced neuromorphic vision systems, especially around event cameras, which is a very fundamental shift and breakthrough in the world of vision-based applications. It has really led to lots of new applications in robotics, in consumer devices, in autonomous vehicles. He's a World Economic Forum technology pioneer. He has wide experience across the electronics universe at Schneider Electric and in fundamental photonics research at Imperial College London. He has a master's in physics and electronic and industrial engineering from Milan and École Centrale, and an MBA from INSEAD. So welcome, Luca. Please, give us a sense of why you went this way. Why did you start a company? Why focus on event cameras and advanced imaging? Why start a company in Paris? What were you thinking?
A good question. Thank you, Chris. And first of all, thank you also, Olga, Evgeny, for inviting me. It's a great pleasure to be part of this event and actually to join this audience today. So actually everything happened in 2014. And so 8 years ago in Paris, I was in Paris at that time, doing an MBA, and by some coincidence, actually, I met my co-founder, CTO of the company, Christophe Posch. Christophe has been working for about 20 years researching neuromorphic vision technologies, so event-based cameras, starting in the early 2000s. And actually, when I met him, he was at that time looking for a first implementation of this technology in collaboration with a company called Pixium Vision, which is also based in Paris, which at that time was actually trying to integrate a first silicon retina, first event-based camera for a visual restoration system to restore sight of blind. And when Christophe actually pitched this idea to me, I was completely overwhelmed. And I didn't have for a second hesitation to tell him, look, we need to start a company and actually bring this technology to the market to serve first this medical application, but also in reality, from the very beginning, was clear to me, was clear to Christophe, that the potential of this technology was much broader, and not only for medical application, but also for industrial, for IoT. Any application that in reality today require vision for some sort of edge computing, edge processing, edge intelligence, to make devices smarter, more autonomous, etc., would have been essentially relevant for this technology to be adopted. And fundamentally, actually, and we can talk about that later, this technology has so much, is so much grounded on biology, on something which is fundamentally so true that for me was becoming really a natural choice and an obvious career step to make. So quitting Schneider Electric at the time and starting this company.
And what are you finding are the big differentiators in the eyes of your customers? So not from a technology standpoint, but from a use standpoint for betting on event cameras and this neuromorphic concept that underlies the fundamental physics and behavior of those devices.
Yeah, so I can actually explain maybe how the technology works, and then how this differentiation translates into customer benefit and customer value. So the fundamental difference is that so conventional cameras, like the one that is currently recording this interview, is functioning by acquiring images at fixed point in time, and this actually way of acquiring information is conceptually quite old. In fact, from the very beginning of photography and then cinematography, we have been doing this. We have been acquiring videos as a sequence of images. Why? Because essentially the main business driver has been, until recently, to do imaging, to display an image or to display a video for human consumption, right? But more and more, of course, and this is also one of the main goal of this community is the fact that we acknowledge and we nurture this trend and this need for more smartness at the edge, right? More and more sensing technologies are used to make devices intelligent and smart, including vision. So, and people have been actually transitioning naturally from using conventional camera, originally fundamentally conceived for cinematography and photography, to actually do computer vision and AI. And this is where you realize that, there are some challenges in terms, for instance, of acquiring tons of redundant data. I think about the video that is currently recording us, right? Probably 95% of the data being acquired over and over by the camera in our laptop are useless, right? Because the background doesn't change. So it's very inefficient. This is issue number one. Issue number two is the fact that this acquisition, as we said, is done at a fixed point in time. So if I start, for instance, moving my hand very fast, or blinking my eyes very quickly, then we will probably lose some of this information. It would be actually very difficult to capture the continuous motion. Plus, you also have some certain drawbacks in terms of limited dynamic range, because typically your exposure time is fixed, right? That's often the issue when, for instance, you take a picture in a lighting conditions where you have in the same scene very bright and very dark part of the scene at the same time. Typically you make a trade-off because you need to choose which exposure time you want to, which part of the scene you want to look at, right? Now, it turns out actually that the human eye doesn't work this way, because there is no image, there is no frame rate, there is no exposure time. So it's conceptually actually built to make us smart, to take a decision in a way locally. So it is actually a very nice, very natural, fundamentally grounded system for edge AI, for edge processing in a way, right? So more naturally actually suitable for the application I was referring before, right? Where machines, devices today require to become safer, more efficient, smarter, et cetera, as opposed to conventional frame-based approaches. So the human eye works in a way where actually, so there is no frame rate, there is no exposure time. So the acquisition is done in an event-based manner. Basically, we only capture the information of what is changing. For instance, when you look at me at this moment, you would basically capture what my hands moving or my eyes blinking. But for instance, the background, which is already known by the brain, is not being acquired over and over. So this makes the system extremely efficient on one side, but also extremely fast. And the fundamental reason why it works this way is because our system need to be extremely efficient. Plus, given the fact that the brain spend maybe 90% of the time to compute visual information, you need actually the human eye, the human retina to be smart at the acquisition level, so at the edge level. Otherwise, the brain would be the size of this room. In addition, it has to be fast because you need to protect yourself from danger of the environment, right? So it seems that the retina has been the organ of the brain of the human body, which has been evolving the most over the course of our evolution, right? So I'm stretching this aspect because when actually Christophe was pitching to me all this benefit back in 2014, it came to me quite natural to say, okay, this is the right technology for all this trend we see in the market, where again, more and more sensors, more and more vision sensors are used to actually make devices, object, machines smarter. And this is what we have been doing at Prophesee, but not only at Prophesee, before Prophesee, in what has been done in research in neuromorphic vision. People have been basically developing vision sensor, so an array of pixels using conventional CMOS technology, but in a way that make each single pixel independent and asynchronous, embedding some sort of intelligence in each single pixel. So rather than actually capture a full image, a fixed point in time at a fixed frame rate, and then reading all this image one after the other, our sensor, in our sensor, each single pixel basically, as soon as it see the change, it will send out this change. And if there is no change in the scene, then there is no data. So, for instance, in this specific example where I'm talking, if we were now having a Prophesee event-based camera, basically you would only capture the contour of my hands moving or my head or my shoulder, etc. But what is static, for instance, the background, it wouldn't be acquired over and over. So this actually reduced drastically the amount of data being acquired on one side. Plus, the acquisition becomes asynchronous, is not really constrained by a frame rate. So the acquisition becomes extremely fast. The pixel react to changes at microseconds. So this actually enables the system to be extremely fast.
Let's talk about some of the implications of the fact that it is not only better in a wide range of applications, but different. Part of the reason people still use conventional CMOS sensors at fixed frame rate is because of the ecosystem of silicon devices to process that format and know-how that's now widely spread across the industry about what to do with conventional fixed sample rate sensors. So as you pursue applications, as you try to win adherence to this new model, what are the most important pieces of the ecosystem that you rely on to make it easy for people to adopt this new form of sensing? Since you can't rely on the fact that there are tens of billions of these sensors produced every year, you've got to kind of build your own flavor of that ecosystem to be successful.
Yeah, is a very good point. And this has been one of the key challenges we have been working on, we have been tackling so far, is the fact that, as you pointed out, Chris, our technology brings a new sensing modality, a new type of signal. So today, at least when we started, there was no ecosystem actually available with ready-made tools to process this data. So what we have done over time has been, first of all, and this has been our, in the end, on one side, one of our main constraints, on the other also an opportunity to actually go end-to-end. So we have been, for instance, ourselves building the chip, of course, but also integrating the chip in the camera module, in the camera system, doing first integration with some compute platform, and then building the software stack to build an entire customer application. So we really, over time, were actually, in a way, constraints to build an end-to-end solution in order to demonstrate the value I was actually explaining before, right? Because all this value intrinsic in the technology, as you actually asked before, how this value of the technology, fundamental to the technology, can actually translate into customer value. You cannot do it, you cannot prove it until you actually do an end-to-end solution. So today,
that's almost a universal characteristic of anybody who's coming to market with new technology, because the new technology is usually not just better, but it's different in some way. And that means that you have to take on more responsibility for the end-to-end solution. But it also creates, in many cases, this dilemma about, okay, now I'm building an end-to-end solution. For whom? For which vertical? Because it's rarely the case that when you're talking about a solution, everybody wants the same thing. So how have you thought about supporting different end applications? How different are they? Which ones did you choose to really put a lot of resources in? Which ones did you sort of let develop on their own? So this vertical question is one of the most fundamental in all of entrepreneurship and the proliferation of breakthrough technologies.
Yeah. So definitely this has been one of the challenges, is the fact that, yes, you start with the technology, you see actually appetite for this technology from different customers, from different markets, from different applications. So what we have done actually, it has been to address the market with a twofold strategy, product strategy. The first one has been actually to create an SDK, a software development kit, so a platform. So we have been actually for some time developing algorithm of computer vision and AI, and finally, after actually 4 or 5 years of internal development, we have decided to put this software offer, MetaVision SDK, now available to everyone in a freemium model, also with an open source architecture, because we really wanted to enable everyone in the ecosystem to actually play with the technology, familiarize with the technology, experiment, invent new things, right? And this is actually where we see traction now, because we have been, since 2 years now, growing a community of more than 7,000 users, and some of them actually, they are now able to bring back to build by themselves an entire solution, entire application. So this has been one strategy. The other one has been for ourselves to actually going end-to-end for some customer opportunities. So we have been doing this for some applications in industrial automation. So this is about high-speed machine vision for quality control inspection. And we are currently doing also for some consumer applications as well, where we see some value for the customer. It's true that for the company, it would be very, very challenging, of course, to go end-to-end for any application out there. So we are now counting on this ecosystem of partners to do so. And for us, our duty now is to focus on few high added value applications where we can put our resources to deliver an end-to-end solution for the customer.
Great. Now, as you're building a venture, there's always some barriers, some discovered problem, whether it's a technical problem or a market problem or a people problem or a financial problem. Can you describe one episode where you had some assumption, you were working in a certain direction, and you really ran into trouble? and you had to pick yourself up and and find a new path.
Yeah, no, definitely. There are different examples. One that was actually quite significant for us has been our focus, for instance, on automotive safety, automotive applications. So when we started the company back in 2014, 2015, of course, the topic around ADAS and autonomous driving was very, very hot. And in fact, if you think about the technology, what we described earlier about low latency acquisition with wide dynamic range, so all these three benefits apply extremely well to safety-related ADAS application, for example, front camera, for any type of autonomy or safety, functional safety applications. So this has been actually a sector that has been naturally pulling us. So we also received investment from Bosch, for instance, from Renault Nissan at that time. And we have been actually engaging several OEMs and tier ones for a while, for more than 2 years, experimenting this technology, trying to prove the value. And actually the value fundamentally was there. The problem, and this is back to what you say, Chris, is that there's in any market, and specifically in automotive, there was a main challenge of scaling up with the ecosystem, scaling up in terms of making the sensor, for instance, ASIL safety compliant, build the software stack with thousands, millions of miles of data, training the model in an ecosystem that at that time and still actually is already on a race for doing the same with conventional technologies, but with different and more comfortable means. And these were actually, after this period of trying, we realized that the challenge ahead of us was extremely high. Even if the technology was fundamentally showing the value, before actually reaching an appreciation by the end customer of such a value, also in economic terms, this would have required for us a long-term investment before actually generating revenue, before actually getting an ROI, which would have justified this investment. And at that time, so this was actually in 2019, we decided to put automotive more for the longer term. Automotive, which until that time was actually our first focus. We said, okay, let's put automotive more for the longer term, because we believed, and we still believe, that the technology will bring value in that market. But let's focus on other market that can actually lead us to shorter term revenue first, and then go for automotive when we will be ready. Us as a company with better financial, let's say, in a stronger financial position, and also stronger with a more mature technology.
Yeah, it's certainly been the case that we all had such high expectations in 2015, 2016, 2017 about the autonomous driving and vision systems for autonomous driving, but it has taken way, way longer to develop into a real market. It's been tough sledding, tough going for those who did pursue it. So it's good to have escaped the siren song of autonomous driving market, especially for startups. It's been very interesting to watch. Now, one of the things I observe over kind of the long history of modern technology entrepreneurship is we had this phenomenon that emerged kind of in Silicon Valley, and an ecosystem that was created there long ago. And lots of different parts of the world said, I want to be like Silicon Valley. But very few places figured it out. And so we did not see high levels of entrepreneurial investment or entrepreneurial success in different parts of the world. And most notably, for a long time, Europe was relatively quiet, despite having, magnificent technical talent and deep research in the university system. But something changed. after about, I don't know, 2000 or 2005, 2010, it seems to have gotten much easier. And there is lots of evidence of quite successful startup activity, especially in France. So what is it about the French ecosystem for entrepreneurship that has allowed this to happen in recent years, in your mind?
Yeah, so I agree with you that especially in the last 10 years, we have been seeing the European scene actually growing a lot with new ventures. Just if you think that 10 years ago in 2012 there were probably around 3,000 deals in venture capital in entire Europe, and 10 years later there are more than 10,000, so 3 times more deals. And if you think about in value, I think 10 years ago was less than $10 billion value, the entire venture capital investment in Europe. Now, last year was 100 billion, so 10 times more. So there's more capital. There's much more capital. And we're not, we are still below US, because I think in 2022, US, although was not a record year, because I think the record year was in 2021, but last year in US was, I think, $250 billion, the entire venture capital investment. In Europe was 100 billion. So we are still 2.5x below US. Nevertheless, 10 times higher than 10 years ago, right? So not too bad, not too bad. In France, I agree. France has been actually growing significantly. Actually, last year, 2022, has been a record year for France in terms of number of deals, in terms of also VC investment. France is number 2 after UK. Historically was number 3 or 4 behind Germany or other Nordic countries. So now number 2, and different reasons for that. I think I would say the first one is the fact that the government has been pushing this ecosystem, the French Tech Initiative, greatly. The President Macron himself has been actually committing on actually sustaining these initiatives, and also the overall country has been also supporting startups with tax credit, with different subsidies. Actually, the BPI, the French sovereign fund, today is the most active European venture capital fund. So all this has been a great support. Plus the visa for talent. So now there are also administrative. So people were actually, I remember when I started the company, talking to some of my friends in the US, they were also raising the concern. Okay, France is but also other countries in Europe. I must say, I'm from Italy, so I understand there are certain complexity in administrative burden, and I think all this has been in a way becoming easier and facilitating the creation and the growth of startup. Where I think still Europe is lagging behind compared to the US. I think it's still in the growth stage, in the support in the growth stage. But I think this is gonna also change over time.
Yeah, well, it's really interesting to see how it's happening. I think that I'm always curious to understand what next. What are the big ideas? What's next technically? What's next in terms of markets? What's next in terms of how you think about building a solution, sort of what's next in your ecosystem? But this is such a technology-driven play. It's more technology-driven than the average startup across tech in general, and even in this semiconductor hardware space, it's pretty far out there in terms of driving a fundamental change to get a fundamental benefit. So what do you think is going to be most important for the success of the business, and where's the technology going?
Yeah. So where I see this technology going is to when I was explaining about this silicon retina, this neuromorphic sensor, event-based camera, all this benefit about efficiency, speed comes with also some drawback in terms of complexity in the design. Definitely more complexity, higher complexity than a conventional image sensor, frame-based. And what has been actually game-changing for Prophesee, and what will be actually in the future also a key enabler for this technology is actually to access more and more advanced process technology for the manufacturing of this sensor. So we have been making, for instance, ourselves a huge step collaborating with Sony and designing our sensor using a BSI 3D stack process. In this process, basically, you can stack 2 wafers, and now you can actually hide, in a way, this complexity and this intelligence, and making the chip smaller, more cost-effective, and opening the door of applications which are more mainstream, more consumer-related, and therefore really unlocking this opportunity for this technology to become a new technology standard. So I think in the future, this trend will remain, because we see advances in manufacturing going from double stack to triple stack, where actually this intelligence close to the sensor or inside the sensor will become more and more sophisticated to make the sensor, the sensing and the computing potentially in the same devices, and enabling better performance in terms of power consumption, in terms of reduced latency, etc.
Mm-hmm. I'm wondering what is going to happen around what's kind of a mismatch, and I'm obviously exaggerating a little bit, but when you have an event-based camera, which essentially has a variable data rate, it's partly why it's efficient, is that it really only needs to send information when something is changing in the scene. But almost all of the machine learning inference engines are more fixed rate. They really tend to want to have a frame update, and those algorithms are somewhat built around the notion of a fixed clock, a fixed data rate coming in. Now, of course, there are some neural engines that would be a natural combination, but that part of the market is much, much less developed than the kind of the frame rate, the NVIDIAs of the world, who provide massive compute power on the assumption that it's a constant data rate. What do you think will change there, or how do you accommodate the fact that you have this suboptimality in the nature of the sensor versus the nature of the mainstream algorithm engines at the level above?
Yeah, so I agree with you that ultimately our goal will be to connect our neuromorphic vision with a neuromorphic processor. For instance, we are also publicly working with Intel, the Loihi neuromorphic initiative. Some of the companies Evgeny was referring before are also taking some neuromorphic friendly architecture, but it's true that the mainstream computing platform like NVIDIA or Qualcomm or others today, they are not yet. I mean, definitely not yet delivering in mass production processor that have this type of architecture. So today, yes, we are facing this challenge. The way we manage it is with a pragmatic engineering approach. So we have actually different representation of the event that we are in a way framing and synchronizing with this conventional architecture. We are still benefiting in this representational event from 2 aspects. One is the fact that our sensor is fast, so you can actually still benefit from the ultra low latency in the acquisition side. And the second, you still benefit from the fact that the event are sparse, and this reduce the computation aspect. But definitely the solution is not perfect, so it has to be
sort of building an integrator on the output of the we have a whole series of questions that have come in, and I urge the audience to send more questions, but maybe we should start to address some of this long list of questions. I'm going to start with a question from Vamshi. How are the processing algorithms, like say object detection, how are they different when operating with an event-based camera versus a frame-based camera capture?
Yeah, so our representation of event of data is based on this in this event of changes. So typically we acquire what is either moving in the scene or is generating event through some active illumination. And then we learn basically from this simple patterns, this time signature of event, so not any more dense and complex images, because what the event-based sensor delivers are essentially edges of moving object. So this is the way basically we extract the information, and then we actually train the models.
Mm-hmm. And Vamshi is also interested in understanding of how does this use of event-based change the inference speed for object detection, or even the accuracy of object detection in ML algorithms?
Yeah, it's probably in the latency we see definitely a major benefit, because the sensor itself actually the time precision of the acquisition is of the microsecond level. Of course, we don't exploit the microsecond, but especially in this effort of integrating the event data, we need to trade off some of this time precision. But nevertheless, we can still keep it at millisecond level. So in terms of latency reduction is something we can definitely in certain application demonstrate. Then it remains, I think, some limitations on the computational side of the inference, but at least on the sensing side is definitely a big benefit we bring. Plus the sparseness, again, what I was referring for, the sparseness of the data in many applications reduce the complexity of the model, so overall reduce also the entire latency of the computational side as well.
Yeah. You seem to have a lot of very practical interest in the audience. There's an anonymous attendee who would love to get more information on what kind of samples you have with different connectors besides USB, and pointers to data sheets for cameras suitable for drones. So there's a do you have any suggestions for people who want to learn more about the available product and its applications?
Of course, there are a lot of information already through the website. They can check about it. So we have actually ourselves developed a number of evaluation kit and reference design kit, with also different connectivity. Plus our ecosystem partners now are also distributing cameras and reference design kit. So this is also another way for the audience to actually acquire acquire our sensor and some evaluation camera and start actually experimenting. We are also offering through our website access to our SDK, which also provide a data set and models for instance for people detection tracking, for car detection tracking. So all this is available. So there are different options that are available.
Great. Vamshi also asks if there are event cameras which still output event frames instead of outputting the events themselves. Sort of, do you have cameras which convert back into frame format?
Cameras that, so if we have a self camera that convert into a frame format, not sure I get the question. I don't know if we wouldn't be able to ourselves to produce an entire, I mean, we can of course produce a frame of event, but we wouldn't be able to produce a frame equivalent to a conventional frame-based camera. Although there are,
and it's not clear that you would want to, since that sort of throws away the benefit.
You throw away a bit of the benefit. So actually there are papers in literature, we have also done ourselves some experiment where you can actually train some model that can learn from event and produce gray level images. But then why you would do that, right? So why? Because in that case you would use a regular camera, which would be probably much more efficient to do that.
Michelle asks, would you say that the events coming out of the camera are analog with respect to the signal, given that time is analog? If yes, how can we exploit the analog nature of these outputs? Yeah,
so the signal out of the sensor is showing basically is giving us information about the position of the event, so the XY in the scene plus the time and the polarity of the change, because change can increase or decrease. It's a relative increase or decrease of light change in the scene. So the closer actually you are processing this data to the sensor, the more probably you are in this analog process. So ourselves, actually, we do some processing inside the sensor to do some filtering, for instance. So in that respect, I think is close to an analog processing. Then I think as long as, so in some application, actually, we are performing some mathematical model that exploit this the nature of this signal. To do some, for instance, some stereo matching for 3D, or using this or using some active markers to illuminate the scene with some special time coded light that can be read easily by the sensor and perform an high-speed 3D point cloud. So in this type of application, we are exploiting the signal closer to its actually analog nature. Of course, the more we move upstream in the computing chain to do more elaborated machine learning based stuff, then I think the more we lose this analog benefit, as we were explaining before, by forcing some sort of integration and framing.
Yeah. George has the question. There's been a lot of attention recently on transformers in neural networks, that particular structure of model that essentially computes a region of attention inside of the neural network model. Have you looked into how transformers might be used in combination with event-based data?
That's a good question. Probably very technical for me. I don't know if probably my team would have as look into that, but I don't.
Okay. Satya Preet asks to compare the output of an event camera with a conventional CMOS sensor or CCD camera. you need to synchronize the two cameras. How is that achievable? Or is that another question for your technical team?
Yeah, no, I mean, we can sync cameras. Actually, this is also documented in the way you can do it, because we do have application where we are actually combining event-based camera, frame-based camera. We use, for instance, event-based camera is great because you can have this always-on, ultra-low power, always-on monitoring of the scene, right? By design, the sensor is always on, it's capturing only if there's a change. So we have application where actually customer is interested to use a frame base only when there is something relevant in the scene. There is something, there's certain specific activity happening, right? Rather than scanning the scene at a fixed frame rate, which would be inefficient, you can use the event camera to capture this information, then syncing with a frame-based camera to actually wake up a full frame acquisition only when there is needed. And this is
got it. Oh yeah, that's interesting.
Yeah.
Okay. A question from Adam. Do you have a rough relative power estimate for your event image sensors compared to a comparable resolution frame image sensor?
Yeah, that's also an interesting question because, while actually a frame-based camera, frame-based sensor, they would typically have a power consumption that may vary, but within a limited range. An event-based camera power consumption can vary in a wider range because it's driven by the activity in the scene, right? If there is no activity, there are no events, there are no data being produced, so the power consumption is very, very low. If there is a lot of activity, then the power consumption increases. Nevertheless, what has been, what we can show, what you can also look from the datasheet of our sensor is typically the power consumption of our sensor in typical scene is an order of magnitude less power consumption than a similar frame-based sensor. So if a frame-based sensor HD is consuming in the range of let's say 200, 300 milliwatt, at certain frame rates, let's say maybe 30, 40 frames per second, our sensor would consume 10 times less. So this on average.
Mm-hmm. I have a clarifying question coming from Michelle, who asked the question about the analog nature of the interface. They say, what I meant was that the signal amplitude or derivative is encoded in the time between events. So we don't need an analog to digital converter to digitize data, and the information is still analog, or at least in the time domain, you essentially have it analog. Is this a great advantage in the eyes of Prophesee? How can you keep it analog during the full computation? I think this is going to tie back into another question from Vamshi, which is how this relates to spiking neural networks.
Yeah,
it's kind of another flavor of that keep it analog spirit.
Yeah, potentially. So we are looking at that, right? So working, for instance, with Loihi and Intel, but also looking at. So we have been actually connecting our sensor to the Loihi platform. Plus, we have been also working closely with SynSense, that is a spin-off of ETH Zurich, working on this SNN architecture. So we have been actually with our sensor. Our sensor is equipped with an analog interface, an AR interface that is sending this asynchronous signal to this SNN type of fabric. And we have been actually showing some benefit in terms of low power and low latency. So this is emerging now on research side with Intel, but upcoming also on a more industry grade side with SynSense.
Yeah. Giraud asks, Prophesee technology appears quite attractive, especially when it comes to protecting privacy, since no image is captured. How could you take advantage of this in AR smart glasses system. What's the marketing argument?
Yeah, it's a very good point, because sometimes we hear this from customer. We have been working with customer, for instance, adopting this the sensor in a smart factory. Actually, the privacy was the main reason why the customer eventually adopted our event camera to monitor basically workers in the factory for some lean manufacturing improvement, because basically the workers didn't want to have a regular camera filming 24/7 while they were operating through workstations. And when they looked at actually the event camera, they said, "Ah, wow, there is no image." So I'm more comfortable with that. So it's part of the. For instance, last year, Xperi, they have been developing a driver monitoring solution using an event camera, and they have trained some neural network to perform a variety of KPI around driver monitoring, like gaze tracking, face detection tracking, to monitor basically the attention of the driver. And one of the marketing claim, which has been also promoted by Xperi, but also well received by some of the OEMs and tier ones currently evaluating this solution, is actually the privacy. The fact that if you pitch this sensor as a new sensing modality, and people they don't perceive this as
that's really interesting. It's almost seems almost ironic, because clearly the camera provides greatest privacy for your background.
Yeah.
If it's anything that holds still is invisible,
right.
Whereas the person who's inevitably moving, well, that's actually captured pretty well. You have this funny thing where you have to argue to the customer, to the user, oh, you get all of the information, and to other people who are worried about, no, you're not getting sensitive information. We're running out of time. I think there's a clarifying question from Dale. How is the how is the temporal signal content of spatial intensity events represented? It's kind of this question of, you seem to have X, Y, T, and direction. Is that really kind of the nature of the data that's coming out?
It is the nature of the data. Is the address of the pixel basically in X, Y, and then the time at microsecond precision of when the change happening, and then the polarity of the change, because a change for us is a relative increase or decrease of light. That's the way the event is being represented.
Yeah, and I think I'll finish on a good question from Vamshi. Does Prophesee or its collaborators provide some short-term internships to work on Explore event cameras?
Yes. So welcome to submit your resume,
or maybe some work. So it's clearly an exciting area where the fundamental technology and the applications you get to serve are really inspirational. So thank you so much for sharing your insights today.
Thank you, Chris. Thank you, Evgeny and Olga, for having me today.
Yeah. And I'm going to pass it back to Evgeny for the wrap up.
Yeah, so I think, thank you, Luca. Thank you, Chris. I think it's been really, really interesting conversation. I think we are definitely wishing Prophesee more success in the future. I think you just raised 50 million euro funding, which effectively made Prophesee the best funded semiconductor startup in Europe, if I recall it correctly. So congratulations. I think it's a big milestone. Will give you enough runway to accomplish even more. But my question to you, Luca, is what does success mean personally to you? Is it like the 50 million funding for your company, or what makes you happy kind of being successful?
Yeah, no, it's not about the 50 million funding. I'm sure, I'm definitely happy of having new investor and people who actually are believers like I am on the future of this technology, and the future of this company, the future my team growing with this company. For me, success in the future means materializing the vision that from 2014, when I started with Christophe, we kind of we saw. I mean, this we believe in a world where there will be more and more intelligence at the edge, and we believe in a world where neuromorphic vision can provide more safety, more intelligence, and more efficiency to these devices at the edge. So that's what. So fulfilling this vision is what will make me happy.
Yeah, I think you're pretty close to this. Yeah, so we wishing you all the best and all the luck to get there. And Christophe, and thank you for joining us again.
Thank you again for sharing so much insight with us.
Thank you, Chris.
And just very quickly, let me acknowledge the sponsors again. This is the list. We have executive sponsors: Edge Impulse, Qualcomm, Syntient. The platinum sponsors partners are DeepLight, ClickerTech, Renaissance, Sony. And the gold partners are Analog Devices, ARM, PhotoHub, Microsoft, NXP, Seed Studio, and tinyML, and ST Microelectronics, Synaptics. And we have a list of silver partners, including Prophesee. Thank you, Luca, again for supporting tinyML. And I think we'll see you at the next tinyML Trailblazers series in a month. Thank you all.
Thank you all very much.